Hello and welcome to Buildings of Tomorrow. My name is John Lester, and in this episode we're talking about demand-based control as part of the hydronic system and its success. Here in the studio I have Chris Kopp, an expert with hydronics and HVAC theory. Chris, thank you very much for joining us.
My pleasure, John.
So please tell us what demand-based control is.
Okay. I think when we look at a hydronic system, we have the consumers, and there we have different demands throughout the year. Sometimes we need more cooling, more heating, less heating. And what we would like to achieve in such a system is to gather information about this demand and bring it back across the distribution all the way back to the production to deliver only as much heating and cooling as is needed at any given time of the operation in the building.
Okay, so understanding what we need at the consumption side, so then we can change how the production and the distribution work so that we can deliver the right amount of energy.
Exactly.
Okay.
Exactly. And now when we think about this demand, we have to figure out a way to measure what is really needed. And one way to do that is to utilize the hydronic circuits and, for example, take the valve position, because it's an indicator of do I need a lot or just a little, and take that as an indicator for the current demand. And then do that, of course, across several consumers, add that up, and then we have the value of what the production needs to create and what we have to deliver across the distribution.
Amazing. So we understand what's going on out there in the fields, and we make that calculation, and we have to make this change at the production scene. Right. Similar to a power station, as an example, producing enough electricity to give a city everything that they need.
Yeah.
Okay.
And now the key is to just produce enough, as you said, and not produce a lot and then figure out later on, oh, we don't need it. Right?
Because if we produce too much, we waste it, correct?
Right, we waste it, we recirculate it unnecessarily. So another important part, besides having this, I would say, control strategy to gather the demand and bring that back to the production and run it based on that, is to make sure that when we deliver this capacity to the consumers, we do that in an energy efficient way, meaning we only move as much water as is currently needed. And so in addition to having the control strategy, we have to ensure that we use the appropriate hydronic circuits that are with variable flow on the supply side, meaning from the production all the way out to the producer, to the consumers.
Okay, so we need the correct hydronic circuit to enable this. Is there any particular features that we need to ensure that we're able to achieve what we would like to achieve with demand-based control?
Yeah, I think we need to select the right hydronic circuits, which would be, for example, a throttling circuit, an injection circuit with two-way valve, or also a mixing circuit, because they are all variable flow between the production and the consumer. But of course, we also have to be able to gather the information about the demand, which means very often we have to have some means in the building automation system to transport this information, meaning we have to gather the valve position, even if it's in a remote location, and bring it back to the distribution or even further back to the production. And sometimes that's a little bit of a challenge, because buildings are parts are far apart in the building, or buildings are far apart amongst each other. And so there we have to find a way, how can we gather this information?
And so this is to understand and collect the information. At the production end, do we have to make any changes or have a special design to enable this?
Of course, the best way is when the producer, the boiler in case of heating, or the chiller in case of cooling, can be also run in a variable mode. Sometimes we call it modulating, or it would be continuous control. And then we can really adjust what is produced at any given time to the demand. What we have to keep in mind there is that these producers can only be modulated within a certain range. You can't drive them all the way down to zero. So initially you have a certain power or capacity that you will provide as soon as it runs. And very often we also then have to think about, what do we do with this initial capacity? If this is 30% of the maximum and we only need 10 or 15%, where does the difference go,
Yeah.
right? And that's when we then might need storage tanks and things like that to really be flexible enough also on the production and in the distribution side.
Okay, perfect. So demand-based control is all about understanding what we need and then enabling the circuit, the distribution control and the production side to make changes to actually deliver exactly what we need within the field.
Yeah. But it's not only the local consumer circuit, it's really the whole setup of the hydronic system. From the consumer across the distribution back to the production, including the pumps. And there also, they have to be the right size. If we have a pump that is way too big, even if we can run it up and down, it might be still too big if we run it at the lowest speed possible,
Okay.
right? So there are a lot of additional things we have to think about than just saying, oh, let's take this hydronic circuit and make the piping between the production and the circuits this and this way. That's not enough. We have to look beyond that and also understand how other parts, the producer, the pumps, really can be operated.
So we have to do some work, we have to make some changes, but is it worth it with the energy savings?
Absolutely, absolutely. Because, for example, the pumps, there is some theory, some physical theory, where we know that when we reduce the flow, the resistance in the piping network gets reduced, and by that, the power consumption gets reduced even more.
Okay.
And these laws are called proportional laws or affinity laws, and they are a very vital part to understand them when we want to do fully demand-based control. So it goes way beyond just knowing the hydronic circuits.
Perfect. So there's additional physical and physics-based things that we need to take into account so that we can be successful in this approach.
Absolutely.
Perfect. Thank you very much for your time.
My pleasure, John.
And thank you all for joining us on Buildings of Tomorrow. Feel free to like, comment and share this episode, and please subscribe to us here on this channel. My name is John Lester and I look forward to seeing you again soon.